Okay, question 16. Here is a cuboid. Leanne says the volume of the cuboid is 0.1 times 4 times 7, which is equal to 2.8 centimeters squared. Write down two mistakes that Lily has made. Lily. Okay. Mistake one is so they've called 0.1 meters. So 0.1 meters is equal to 10 centimeters. So she has not converted correctly. That would be mistake one, and mistake two, I'm going to look at that. Unit of volume should be meters cubed. Centimeters cubed, because that's the unit that we're using. Centimeter squared would, of course, be a unit of area. Okay, so marks for that then. We are picking up. What does the mark scheme say? One correct statement, B1, should have converted 0.1 meters to 10 centimeters. And mistake 2, she has written centimeters squared instead of centimeters cubed. So B1 and B1. Right, question 17. Make P the subject of the formula. Okay, so let's start with H is equal to 6P minus 7. And our first step is going to be, we want P to be the subject, so we're going to add 7 to both sides. So H plus 7 is equal to 6P. And then divide both sides by 6. It gives us P is equal to H plus 7 divided by 6. And straight to the mark scheme then, M1 for the correct first step of adding 7, so technically that's there, M1, and then A1 correct answer only. Right, question 18. So 120 people go to the zoo, 65 of the people are children, 15 of the adults have season passes, 3/4 of the children bought day tickets. Complete the frequency table for this information. Right, let's just make it. Okay, so we've got 120 people already added, 64 of the people are children, so we've got 64 there. I'm just going to add the information from the question first of all. 15 of the adults have season passes. So that's the information I can put in for now. Oh, actually, 3/4 of the people brought day tickets. So if I'll do it up here. 3/4 times by 120 is going to be 30. Is going to be 90 people. So I know that day tickets has to have a total of 90. Right, so that's basically extracting information from the question. Typically call these processing marks, and then I'm going to go for the number of adults. So if there are 120 people in total, and we know 64, that leaves us with 56 adults. And then if we know that 15 of those adults have season passes, so I'm going to do my last answer minus 15, so I should have 41 people with day tickets, and I know that that's got to equal 90, so 90 minus the answer gives me 49 children with day tickets, and then 64 minus the answer that 64 minus the answer that I just worked out, 49, it should give me 15 season passes. Okay, and part B, one of the children is picked at random. So we're picking from the children, so that tells us straight away that our denominator is 64. What is the probability that the child has a season pass? So I'm going straight for 15 have a season pass, so 15 out of 64. We can use our calculators to simplify that, although it doesn't ask for it in its simplest form. I'm not 100% certain it will cancel, but yeah, so 15 out of 64. Right, mark scheme then. So, colour that we've not used, let's go green. Okay, M1 for 64 adults, for 56 adults and 64 children, so kind of for that stage there. M1 for 15 and 41, so another M1 there. And actually it says up here, 3/4 of 120 is 90, so M1 there as well. And then an A1 for all correct values. And then for part B, we're looking at 15 out of 64. A1 for correct numerator, followed through from earlier. And then A1 for fully correct answer. Okay, diagram shows a solid prism. On the centimetre grid below, draw the plan of the solid prism. So that's the view from above, really. So if we kind of just look at the dimensions to start with, we're going to see that from above, technically that from above, and then we'll actually see that edge as well. So pick a place to start. I know that we're going to see this edge here, which I'm going to draw first of all, and that's going to be 5 centimetres. On the centimetre grid, so I'm going to assume that this is a centimetre grid. So there's my 5 centimetre line. I'm going to have a 4 centimetre line. Then I'll have this edge down here, which would be this edge here. And then I've got a 3. So that's going to be my view from above. Okay. So marks for this then. So we're picking up M1 for correct fully shape, A1 for correct rectangle with measurements 5 centimetres by 7 centimetres split by the diagram. So M1 and A1. And there's a part B that I missed. Write down the number of vertices that this prism has. So vertices are so where edges meet. So we've got 1, 2, 3, 4, 5, 6, and we'd have the same on the other side. So we're going to have a total of 12. I actually did 6 times 2 there, but and the marks for that are just a B1 for the 12. And question 20, on the grid below, draw the graph of y is equal to 3x minus 1 for the values minus 1 to 3. So I'm going to do this from the equation of the line. So y is equal to mx plus c. So the gradient of this is going to be 3, and the intercept on the y-axis is going to be minus 1. So I'm going to start with the intercept on the y-axis. So we're looking there. And then for every 1 across on the y-axis, so that's in effect 2 squares here, I'm going to go up 3 squares. So for every 1 across, I'm going to go up 3 on the x-axis. For every 1 across on the y-axis, I'm going to go up 3 on the x-axis. And the same in reverse. For every 1, I'm going to go down 3. So that's going to be my line. And that's it for that question. We could have done it from a table of values, of course. And there's nothing wrong with that. So in the table of values, we would have had to have done minus 1 and 3, and I would have probably done another value as well. So those are my values for x and what y would be at those times. You only need 3 values. You can do more if you want, but 3 is more than enough for a straight line. It's 2 to get the straight line, 1 to check. So if x is minus 1, 3 times minus, that would be minus 4. When x is 0, we've got minus 1, and when x is 3, that would give us 9. Minus 1 would be 8. So that's called from table of values, and we've done it. The way I did it first of all was from the equation of the line. Right, marks for that then. So M1, table of values or pairs of values with at least 3 correct. M1, at least 3 points plotted correctly or points drawn correctly. So in effect, it was M1, M1, A1. Okay, question 21. The scatter diagram shows information about the cooking times of various cakes. So we've got the mass and the cooking times. Here's some information about another 3 cakes. Plot this information on the scatter diagram. Okay, so at 750, we've got a cooking time of 35 minutes. So that would be, that's 30, slap bang in the middle there. Then we've got 850. And a cooking time of 50 minutes, so that would be there. And then finally we've got a mass of 700, which is down here, and a cooking time of 20. That's my 3 points added. Plot this information on a scatter diagram. What type of correlation does this diagram show? So that shows a positive correlation. And final part, use the scatter diagram to estimate the cooking time of a cake which weighs 900 grams. So, looking around my room for a ruler. Okay, so it's not going to work particularly well. So unfortunately I don't have a ruler or anything really similar, so I'm trying to use a straight edge of paper. So I'm going to go roughly there, but that's not going to draw on. Hold on a second. Okay, we'll try that again. So I've managed to find a straight edge. I'm thinking that looks that's about as straight as I can get. That's a little bit low. So I'm actually not happy with that, so I'm going to that's a little bit too high. So I'm going to go there. Oh gosh, apologies. I'm still not happy with that, unfortunately. I'm gonna say that will do. So you're after a line of best fit that best matches the data, really. So unfortunately, I've not got good enough ruler to work on my electronic screen, but that will do for now. So use the scatter diagram to estimate the cooking time for a cake which weighs 900 grams. So I'm going to go 900 grams up to my graph. Where it hits, I'm going to go across. So I'm looking at 48 by my graph. So I'm going to go 48 minutes. Right. So marks for that then. For the first part, plot the 3 points. We have got M1 for 1 point plotted correctly and A1 for all 3 points plotted correctly. So we'll go M1, A1. Just looking, and they do agree with me. Type of correlation, positive for B1 mark. And then finally, we're going M1 for a line of best fit. And A1, they agree with me 48 minutes, but they've said anything between 46 to 50 is acceptable. And question 22, here's a rectangle and a trapezium. The area of the rectangle is 40% greater than the area of the trapezium. Work out the length of the rectangle. Okay, so I'm going to start by working out the area of the trapezium. So the area, I'm going to call it AT for area of trapezium, is going to be equal to a half of 6 plus 9 times by 4. So I'm going to change that to 15 times by 2. What I've done there is halve the 4, which gives me 30 centimeters squared. And we're told that that is the area of the rectangle is 40% greater. So I want 40% bigger than that. So I'm going to do 30 times by 1.4. That's 40% increase. So 40% increase has a multiplier of times by 1.4. 140%. So 30 times by 1.4 gives me 42. So the area of the rectangle is going to be 42. 42 is going to be equal to 4 times by, let's call the length x for now. So x is going to be equal to 42 divided by 4, which is going to give me 10.5. So 10.5. Okay, and the marks are awarded for A1 for the area of the trapezium being 30 centimeters squared, so A1 there. M1 for 40% of their area, correct. So we'll go M1 there. M1 for area of a rectangle being equal to 42, so M1, and then A1 for 10.5. Question 23. A box holds 12 donuts. It takes 40 grams of flour to make 20 donuts. Linda needs to make 4 boxes of donuts, and she has 1.5 kilograms of flour. Does Linda have enough flour to make 4 boxes of donuts? If we work out first of all how many donuts she needs to make, so we want 4 boxes of 12. So 12 times by 4 would give us 48. So she needs to make 48 donuts. We need 500 grams to make 20 donuts. So if I say that 20 donuts uses 500 grams of flour, then in effect I can say we'll do it this way. So that basically means that 2 donuts will require 50 grams. So 48 donuts would require 50 times by 24. So I'd need 1,200 grams of flour, and 1.5 kilograms of flour is equal to 1,500 grams. So does she have enough? Yes. She needs, right. Just switching pens. Is that going to work now? Okay. She needs 1.2 kilograms of flour and has 1.5 kilograms. Okay. And if we go to the mark scheme then, so the mark scheme is suggesting M1 for attempt to use proportion to find the amount of flour needed for 12 or for 48 donuts. So we go M1 there. M1 for 300 grams for 12. 1.2 kilograms seen. So I've actually gone a bit further than I needed there. We'll go M1 there, M1 there. and it's actually suggesting, right, that makes sense. So it was an M1 for suggesting 48, an M1 for using proportion, and A1 for correct statement following correct working. So that's my 4 marks. Question 24, solve the simultaneous equations. Okay, so the idea behind simultaneous equations is we either need to make our A coefficients the same size, whether that's positive or negative, or our B's the same size, whether that's negative or positive. So what I'm going to do is I'm going to make my B's the same size. So to do that, I'm going to make them both 6. So I'm going to take equation 1. So I'll take equation 1 and I'm going to multiply that by 3. That would give me 9a plus 6b is equal to 60. And I'm going to take equation 2 and multiply that by 2. And that would give me 8a minus 6b is going to be equal to 25. My next step then, I'm going to call that equation 3 and equation 4. And I'm going to add them together because that will cancel out my b's. So 3 plus 4, equation 3 plus equation 4 would give me 17a is equal to 85. I'm then going to divide both sides by 17 to get a is going to be equal to 5. Let's just double check. 85 divided by 17 does give me 5. Right, I'm then going to take my value of a and substitute it into one of my initial equations. And I'm going to substitute it into equation 1. So 3 lots of a becomes 15 plus 2b is equal to 20, meaning that 2b is going to be equal to 5. So b would be equal to 2.5. And I'm going to finish off with a quick check. This is worth 3 marks, so spending 30 seconds doing a check is well worth it. So I'm going to check with equation, the one that I didn't use there, so equation 2. So 4 lots of a becomes 4 times 5, that would be 20. Minus 3 lots of b, so minus 7.5. That would be equal to 12.5, and we want it to be 12.5, so I know that I've got that right. So a is 5, b is 2.5. So a is equal to 5 and b is equal to 2.5. Right, we have got M1 for converting both equations to make coefficients of a or b equal and attempt to add or subtract equations. So we will go for M1 there. And A1 for either 5 or 2.5. And then second A mark for both being correct. And question 25. So ABCD is a quadrilateral made of 2 right-angled triangles. Work out the size of angle X, giving your answer correct to 1 decimal place. So we're going to have to use, I'm going to call this length here Y. I'm going to have to work out this first of all. And then once I've done that, I can work out X. So Y squared is going to be equal to 13 squared minus 5 squared. That's Pythagoras' theorem to work out a shorter side. So y squared is going to be equal to 13 squared minus 5 squared, minus 5 squared. So that's giving me the value of 144. So y is the square root of that, which is going to be 12. So from there, I'm going to say that this is the angle that I'm looking for. I'll change pen color just to show that this is my second stage of working. This is the opposite side, and then this is the adjacent side. So I'm going to be using my tan ratio. So tan is equal to the opposite over the adjacent. So I am trying to work out the opposite side. So the opposite, so O is going to be equal to T times by A. And then I'm going to substitute in. So Oh no, I'm trying to work out the angle. I was getting myself confused because I'd labelled it y. So I'm trying to work out the angle. So the angle, which we should be calling x, is going to be equal to tan to the minus 1 of the opposite over the adjacent. So 12 over 10. And I'm just going to type it in just like that. So shift tan, we always do the inverse when we're trying to work out an angle. Using trig, 12 divided by 10, close my bracket, and that gives me the value of 50.1944. So I'm going to write it down to a greater degree of accuracy than needed, and then put dot, dot, dot to show that I've not rounded. And then I'm going to round that to 50.2 to 2 decimal places degrees. Okay, right, so marks for that. And I'll use green. So we have got M1 for seen or implied using Pythagoras. So M1 there, and then an A1 for 12. And then an M1 for using tan, and then an A1 for my value. Right, 26. Here are 4 graphs. So we've got this graph A is going to be a quadratic, or looks like a quadratic. Graph B is a linear with positive gradient. This is a reciprocal graph, and this is a cubic graph. Write down the letters that could have been the equation. So positive linear, so that would be graph B. Cubic, which would be graph D. And then the reciprocal, which means 1 over x, that would be C. And that's the only part to that question. So we have got A1 for each response. So A1, A1, A1. Okay, here are 2 column vectors on the grid. Draw and label the vector 2a plus b. Okay, so if we go straight from the columns, so 2 lots of a would be, so let's say 2a plus b would be equal to 2 lots of a would be 6, and then b plus b would be minus 1 over 2 lots of a, which would be 2 plus 2. So we're going to be drawing the vector of 5, 4. So pick a point to start. So let's start there. And I'm going to go 5 across, 2, 4, 5, and 4 up, 2, 4. And doing that with a straight line. Again, so there we go. And we show the arrow to show the direction of the vector. Okay, and marks for that then. And actually, I'll do this on here. So we could have started there and said 2 lots of A would have been 3 across and 1 up, and then another 3 across and 1 up. And then B is 1 to the left and 2 up. So we could have kind of drawn it as that if we'd have wanted to. A, B, and then that's our resultant vector. Right. So marks for that. We have, let's go purple, green. So M1 for vectors A and B drawn on the grid, M1 for vector 2A, seen or implied, A1 for correct value of 2A plus B, or M1, M1, A1. So we could go M1, oops, M1, M1, A1 would be absolutely fine. And that brings us to the end of the paper. Thank you very much for taking time to listen to this video. Again, Just to say it again, I've used Third Space's learning paper for this walkthrough. Very useful revision site if you want to get in touch with them. Thirdspace.learning.com. Thank you very much for your time in listening, and I will see you soon.